Welcome everyone. In this session we are going to discuss about the JavaScript data types and their unique characteristics. So what are waiting for? Let's start. JavaScript provides two types of data types. First, primitive data type, which are number, string, boolean, null, undefined and symbol, which is available only from ES6. And the second one, non-primitive or reference data type, that is an object. JavaScript is a loosely or dynamic typed language, therefore a variable does not associate with any type. However, its value does. That is, the same variable can hold values of different types at any time. For instance, where department equals 30, here department holds a number. Department equals false. Now department holds a boolean. Department equals sales. Now department holds a string. Let's initiate with the number data type. The number type serves both for string and floating point numbers. Let's have a look for integer numbers. For instance, where num equals 100. This statement declares a variable num which holds an integer value 100. If we want to represent a binary that is base to literals, we must use 0b, that is b in lowercase, as the first two characters, followed by binary digit numbers, that is 0 and 1. For instance, where bin num equals 0b, writing the 1 8 times. That is binary representation for 255. Console.log of bin num. Reload the page. The generated output is 255. If we want to represent the octal, that is base 8 literals, we must use 0o, that is o in lowercase, as the first two characters, followed by octal digit numbers, that is from 0 to 7. For instance, where octnum equals 0050, that is octal representation for 40. Console.log of octnum. Now reload the page. The generated output is 40. Hexadecimal numbers are widely used in JavaScript to represent colors, encode characters, and for many other stuff. To create hexadecimal, that is base 16 literals, we must use 0x, that is x in lowercase, as the first two characters, followed by any number of hexadecimal digits, that is from 0 to 9 and from A to F. For instance, where hexnum equals 0xd, that is hexadecimal representation for 222. Console.log of hexnum. Now reload the page. The generated output is 222. Let's have a look for floating point numbers. For instance, where num1 equals 123.45. To represent a floating point number, we include a decimal point followed by at least one number, where num2 equals 0.5. 0.5 is valid and same as 0.5, but always recommended to use 0.5. Console.log of num2. This evaluates to integer 0.5. JavaScript converts a floating point number into an integer number if the number appears to be the whole number. The reason is that JavaScript always wants to use the less memory, since a floating point number value uses twice as much as memory as an integer value. For instance, where num3 equals 200.00. Console.log of num3. This evaluates to integer 200. Now reload the page. The generated output is 0.5 and 200 as we discussed. JavaScript allows us to use the E notation to represent very large or small numbers. For instance, where billion equals 7.3 E9. Here we shorten the number by appending the letter E to the number and specifying the zeros count. Hence, 7.3 E9 is equivalent to 7 followed by 3 with 8 zeros. Console.log of billion. Now reload the page. The generated output represents 7 followed by total 9 digits, which includes 3 with consecutive 8 zeros. Let's write something which is very small, for instance 1 microsecond, that is 1 millionth of a second, where ms equals 1.23 e minus 6. Here we avoid writing the zeros explicitly by appending the letter e to the number. Console.log of ms. Now reload the page. The generated output represents total 6 zeros to the left from 123 with decimal. JavaScript provides the minimum and maximum values of a number that we can access using number.min_value and number.max_value. In addition, JavaScript also uses infinity and minus infinity to represent the finite numbers, both positive and negative. For instance, console.log of number.max_value, console.log of number.min_value. Now reload the page. The generated output represents the maximum and minimum values of a number. Besides regular numbers, there are so-called spatial numeric values, that is infinity, minus infinity and nan, which also belong to this type. Infinity represents the mathematical infinity. It is a spatial value that's greater than any number. For instance, console.log of 1 divided by 0. This evaluates to infinity, which represents an operation where a number is divided by 0. Console.log of number.max_value plus number.max_value. This evaluates to infinity. Console.log of minus number.max_value minus number.max_value. This evaluates to minus infinity. Now reload the page. The generated output represents the way to achieve infinity and minus infinity. Let's have a look for nan, which stands for not a number and represents a computational error. It is a result of an incorrect or an undefined mathematical operation. In fact, it means an invalid number. For instance, console.log of not a number divided by 5. This evaluates to nan, which represents the division of a string by a number. Now reload the page. The generated output is nan. nan has two special characteristics. First, any operation with nan returns nan, that is console.log of nan divided by 2. This evaluates to nan. And second, nan does not equal to any value including itself, that is console.log of nan double equals nan. This evaluates to false. Now reload the page. The generated output represents nan and false for their respective operations. Now let's understand the string data type. A string is a sequence of two or more characters. A literal string begins and ends with either single quote or double quote or backticks as a part of ES6. Here, point to be noted is that a string that begins with a single quote must end with a single quote, and the same rule is also applicable for double quotes and backticks. For instance, console.log of sales followed by plus operator /t plus department in double quotes. Double and single quotes are simple quotes. There is no difference between them in JavaScript. Besides regular printable characters, special characters can be encoded using escape notation, like single quote can be represented by slash followed by single quote, and tab can be represented by /t. Now reload the page. The generated output is sales department. Let's check the usability of backticks also, where name equals Smith. Console.log of welcome, $, followed by curly braces, name. Backticks are extended functionality codes. They allow us to embed variables and expressions into a string by wrapping them in $ followed by curly braces. Now reload the page. The generated output illustrates the example of a string. In this case, the expression or variable access inside $ followed by curly braces is first evaluated, and then the result finally becomes a part of the string, that is welcome Smith. Strings are immutable in nature. It means that we cannot modify a string once it is created. However, we can create a new string based on an operation on the original string. For example, where str equals string, here we declared and initialized the variable str. Str equals str plus immutability. Console.log of str. Now reload the page. Behind the scene, JavaScript engine creates a new string that holds the new string, that is string immutability, and destroys the other two original strings, that is string and immutability. Moving ahead, now let's understand the Boolean type, also known as logical type. Boolean. The Boolean type has two values, that is true and false, exists in lowercase. For example, where is ename validated equals true, where is age validated equals false. Here these two variables hold Boolean values, where is greater equals 50 greater than 10. Console.log of is greater. Now reload the page. The generated output represents the Boolean type that is true since 50 is greater than 10. JavaScript allows values of other types to be converted into Boolean values of true or false. To convert a value of Boolean data type into Boolean value, we need to use the Boolean function. Let's have a look for the conversion rules. For a string type, when it's non-empty string, then it evaluates to true, but when it's empty string, then it evaluates to false. Please pause the video and kindly have a look for the types number, object and undefined. Moving ahead, let's verify these conversion rules through the illustration. Console.log of Boolean of string hello. This evaluates to true. Console.log of Boolean of empty string. This evaluates to false. Console.log of Boolean of 500. This evaluates to true. Console.log of Boolean of infinity. This evaluates to true. Console.log of Boolean of 0. This evaluates to false. Console.log of Boolean of nan. This also evaluates to false. Now, console.log of Boolean of inside the curly braces century colon 100. This evaluates to true since the evaluation happened on non-empty object. Console.log of Boolean of null. This evaluates to false. Console.log of Boolean of undefined. This evaluates to false. Again, reload the page. As expected, the generated output represents their respective Boolean value when evaluated by the Boolean function. Now, let's understand the null type. The null type has only one value, that is null. The value null represents the intentional absence of any object value. In simple words, it's just a spatial value which has the sense of nothing, empty or value unknown. For instance, where job equals null. It is a good practice to assign a variable that later holds an object to null so that we can check whether the object is either null or not by using the if statement like if job is not equal to null, then only execute the logic. This represents execute the logic only when the job is not equal to null. Now let's understand the undefined type. The undefined type has one spatial value undefined. By default, when a variable is declared but not initialized or not defined, resulting it is assigned the value of undefined. The meaning of undefined is value is not assigned. For instance, where ename console.log of ename. This evaluates to undefined. Now reload the page. The generated output represents undefined since the variable ename is not initialized. Now let's understand the symbol type. JavaScript has a new primitive type in ES6, that is the symbol. The symbol type does not have a literal form. To create a symbol, we need to call the symbol with an optional description. For instance, where sim1 equals symbol. Note that symbol is a function, not an object constructor. Therefore, we cannot use the new operator. If we do so, we will get a type error. The symbol function creates a new unique value every time when we call it, that is console.log of symbol double equals symbol. Now reload the page. The generated output is false only since a new unique value got created every time. We can even pass a descriptive string to the symbol function for logging and debugging purposes. For instance, where sim2 equals symbol event.save. When we call the toString method on the symbol variable, it returns more descriptive name, that is console.log of sim2.toString. This evaluates to the string representation of symbol variable. Now reload the page. The generated output is symbol of event.save. We can use symbols for many purposes. One of them is to create a string-like constant that cannot clash with any other value. For instance, let's create a symbol that represents the click event. Const click equals symbol click. The string click may be used for different purposes and is not unique. However, the click symbol is unique. Now time came to understand the object type. Object. In JavaScript, an object is a collection of properties where each property is defined as a key value pair. In short, an object is capable of storing multiple values as properties. In JavaScript, all objects are derived from the object type. For instance, an empty object can be created by using either of the two syntaxes. First, where dpt equals new of object. This statement defines an empty object named dpt by make use of object constructor syntax. And the second one, where emp equals opening closing curly braces. This statement defines an empty object named emp by make use of the object literal syntax. Usually the curly braces are used. This declaration is called an object literal. An object can be created with curly braces with an optional list of properties. A property is a key colon value pair where key is a string, also called a property name, and value can be anything. Now let's define the emp object with the two properties. Where emp equals opening closing curly braces first name colon Smith. A property has a key also known as name or identifier followed by the colon and a value to the right of it. And if we have more than one property, then use comma to separate the pairs. Last name colon Weber. Hence, got created with the employee object, which consists of two properties. The first property has the key first name and the value as Smith, and the second property has the key last name and the value as Weber. JavaScript allows us to nest object. For instance, where contact equals first name colon Jack, comma last name colon Roy, comma email colon abc@gmail.com, comma phone colon 3 times 4, 3 times 5, 4 times 6, comma address colon city colon Oakland, comma state colon California, comma country colon USA. The contact object consists of first name, last name, e-name, phone, and address properties. The address property itself is also an object that consists of city, state, and country properties. We can access properties of an object by using two notations, either by the dot notation or array-like notation. Let's have a look for the instances which uses the dot notation to access the first name and last name properties of the contact object. Console.log of contact dot first name, console.log of contact dot last name. To get a property of a nested object, we use the form that is console.log of contact dot address dot country. If we refer to a non-existence property, we will get an undefined value. For instance, console.log of contact dot age. This evaluates to undefined. Now let's have a look for the instances which uses the array-like notation to access the email and phone properties of the contact object. Console.log of contact phone, console.log of contact email. Now reload the page. The generated output represents the values of the properties of an object contact which are accessed by dot notation and array-like notation. Besides the object literal form, we use the new keyword to create a new object. For instance, where client equals new of object. Now assign a value to the property of the object. Let's add a new property named company, that is client.company equals Apple Inc. Console.log of client.company. Now reload the page. The generated output represents Apple Inc. That is the value of the key company of client object. Moving ahead, let's have a look for the type of and instance of operator. Type of operator. Type of operator returns a string indicating the type of the unevaluated operand, that is, it returns the type of the argument passed. For instance, console.log of type of 0, console.log type of welcome, that is string, console.log type of true, console.log type of null, console.log type of undefined. Now reload the page. The generated output represents the type of the argument passed, that is, for 0 it's number, for string welcome it's string, for true it's boolean, for null it's object, and for undefined it's undefined. Similarly, other available types can also be checked by this operator. Now let's have a look for instance of operator. Instance of operator is used to check the type of an object at runtime. It returns a boolean value that indicates if an object is an instance of a particular class. For instance, where str equals new of string testing. Here we declared a string object where dt equals new of date. Here we declared a date object. Console.log str instance of string. This evaluates to true as str is an instance of a string object. Console.log of dt instance of date. Also evaluates to true as dt as an instance of date object. Now reload the page. The generated output represents whether an object is an instance of a particular class or not.